this video, I'm discussing about the multicollinearity. Dear friends, it is very important assumptions when you are going to apply the multiple regression. There are total 8 assumptions. And multicollinearity is another important assumption from these 8 assumptions. In this video, I will discuss about I will define firstly multicollinearity, what are the sources of multicollinearity, and what are the impact of the multicollinearity. These things I will discuss in the theoretical part of this video, and in the practical section, I will tell you how you can identify the multicollinearity through the species, and then how you can remove the multicollinearity from your data if it is available. My name is Dr. Rahim Sumro, and I'm from Shabati University, Pakistan. Multicollinearity is a part of the data screening. In this umbrella of the data screening, earlier my videos are available on missing data, outlier, normality, linearity, homozygosity. And this is the last video of this series, data cleaning, and that is about the multicollinearity. Multicollinearity, what is first of all, we understand what is multicollinearity. Very easy, it is very easy to understand. You know that in the multiple regression, especially when you are going to apply the multiple regression, not the simple regression. Please, there is a difference between the multiple regression and the simple regression. In the simple regression, there is only one dependent variable and one independent variable. While in case of the multiple regression, there is a one dependent variable and more than one, there are the independent variable. Now, different words, different terms are being used for the dependent and independent variable, different. So there's you are looking at one list where the different names have been mentioned about the of the dependent variable and of the independent variable. But in multicollinearity, what's happened? There's a journey occurs when there is a high correlation between the two or more predictor variable. Now here predictor means independent variable, and here the predicted means the dependent variable. Now multicollinearity simply that means when there is a high correlation between the two or more independent variable, not dependent variable. This is called the multicollinearity. Now, example of multicollinearity are like the a person's height and weight. Most of the time, you're finding some high correlation between the height and the weight, age, and the sales price of a car. There's also another source of the multicollinearity: year of education and the annual income. As you that means the education you are increasing, at the same your income is also being increased. So most of the time, these are some of the example where you will find most of the time the high correlation, because there is a high correlation among the between or among the independent variables. And then please, again, I'm repeating the same thing, that this assumption is only valid for the multiple regression. If you are running simple regression, then there is no only question of the multicollinearity, because there is only one dependent and the one independent variable. If you are performing a simple linear regression, skip this assumption, and you can check multicollinearity in two ways: through the correlation coefficient. By entering into correlation, you can find out the relationship between the two independent variables or several independent variables. If the relation between the two variable or several variable is more than 0.8 or more than 0.8, then there is a problem. Possibly there is a multicollinearity between these two variables. And another method is about the variance inflation factor. Now, if the values are above that means the 10, it means the multicollinearity exists in your data. If the values are less than 10, okay, suspectedly, we are not sure, but we are suspected that, okay, possibly the multicollinearity may exist. But if it is less than 5, that means there is no issue of the multicollinearity. Data is means a clean data. In this way, you can run the multiple regression on that data. You can check multicollinearity in two ways, as I told you, correlation coefficient as well as the variance inflation. Now, if the value of the variance inflation factor is 1, it means it's not correlated. If it is between the 1 and 5, moderately correlated, and if there's greater than high, then highly correlated. But again, that means the values are 10. If the values of the VIF are more than 10, that means you must be anxious about the multi-collinearity. But if the values are less than 10, I think there is no any multi-collinearity. From my own practice, I'm telling you. Causes of multicollinearity, what are the causes? The first cause is insufficient data. The data is insufficient, probably that's why the multicollinearity issue may arise. Now, if you provide the sufficient data, if you collect more data in the meter, and then probably you can solve this problem. Dummy variables, sometimes we are required to insert a dummy variable like the male, female, spring, summer, autumn. So these are also a one source of causing multicollinearity, and then including the variable that regression, that is actually combination of the two variable where you are inserting in another variable which is creating a, that means like the high correlation between the two variable. That is another reason of the creating multicollinearity. Like total investment, when the total investment income equal to income from the stock, bonds, and plus income. Now, if this is the example, if you are inserting another variable like the total investment income, it may create a multicollinearity in your data. Okay, so another source of multicollinearity in your data is identical or almost the same variable. The weights in pounds and the weights in kilo, now these are almost the same. Now, this is another source of the multicollinearity. Are the investment income saving bonds? So sometimes these are the sources of the multicollinearity in your data. Now, this is the one type of the like the result from coefficient result when you are applying the multiple regression. In this one, here basically collinearity diagnostics are statistic. In this one, tolerance and VIF. So now here we are interested in the VIF. Now you see that the parents, now its VIF is the 2,434, and then each parents, average parent, now this is another 2009. Now it is highly correlated data, and high level of multicollinearity is existing in this data, because these are the very much high than the 10. So the maximum value is 10. If the VI are increased to 10, then surely there is a collinearity in your data. Now, why data? Now, see, in the same way, parents and the average parent. Now, parents and the average parent. Now, the problem is a clear from this one. There's a negative relation between these two variable, and it is about the 0.825. That means more than 8. Then again, parent and then in here, there is also a multicollinearity, because there is high correlation between the two variable 0.8 to 0.809. So these are the major two issues. Because of that one, the multicollinearity is available in our data. Again, I'm repeating that the range of the correlation is 0.3 to zero point 0.7. If your values are within this range, this is the acceptable range. Now, checking multicollinearity, now the data is available. So at the end of this data video, you will find the link of the data which I'm going to use right now for the practical purpose. You can download this data and you can do all these things by yourself. Dear friends, again, I'm repeating that whenever I prepare any video, I usually refer these three books using species, statistic, species, and a survival manual by Julian Payment, a very strong and advanced book discovering statistic using IBM statistic, written by Andy Field. So, and then I always refer these books. I also personally suggest you please go through these books, because these will aid a lot of knowledge in you regarding the use of the species. Dear friends, let's move towards the practical section of this video. In this video, there are this is a data set. In this one, there are the four independent variables, and one is a dependent variable. So now here we are going to check either the collinearity is available in this data or not. Again, I'm repeating this assumption is important when you are applying the multiple regression. If you are applying the simple regression, then there is no need to meet this assumption. Okay. Now go into the analyze, then go into the regression, and linear regression. Do not do just reset it, okay, and move your dependent variable in the dependent variable column and your four independent variable in the independent variable column. Then press the button statistics and go and just check the collinearity diagnostic. It will produce the values of the VIF and then press continue and then OK. These are the different tables are available before you, but we are all interested in the coefficients table where our results of the VIF are available. In that one, when you see that the values IV1, IV2, these are below the range of the 10, that's okay, there's no any problem. But in the IV3 and IV4, there is a one issue. The issue is that their values are higher than 10. If the VI value is higher than 10 of any independent variable, it means there is a problem. Here, the values of the IV3 and IV4 are more than the 10. It means that there is an issue of the multicollinearity. Now, in the theoretical section, I discussed the two methods are there. One was a correlation, another was the variance inflation factor, VIA. So through the variance inflation factor, we have come to know that there is a problem of the multicollinearity with this data set. Now, another method is correlation. How to go? Just go into analyze, correlate, bivariate, correlate, and then reset, and then move IV4 1 to 4 because there is no need to insert the dependent variable in that one because here we are going to find out the relationship between the correlationship between the among the all the independent variables. So now here if you do not want to insert a dependent variable, then there is no any matter, just press OK. These are the values of the correlation. In that one, the IB1, independent variable 1, independent variable 1, 2, 3, 4 independent variables are there. Their values are available here. And then what you do that the first of all, we have to segregate these one into the two sections. How to do? That means just create a one line which will divide this whole into the two one. Now, from this side or from this side, the values are exactly same. There is no any difference. Now, this is the horizontal line, this is a vertical line. Horizontally or vertically, whatever you want to read out. Now, either on the from here, read this part of the table or this part of the table. No any problem. Now, here in this way, if you see IV, okay, between the IV2 and IV1, it is all 0.8. Then the relation between the IV3 and the IV2, 0.9. That means quite high than 0.8. That means there is a problem of the multicollinearity. Then again here between the IV4 and the IV, like this one is IV3 and IV4, the relationship between is a 0.93. So now these three are there, even though this one. So now these are clearly showing that there is a serious issue of the multicollinearity with your data. Okay. Alternatively, another method is there to check out how frequencies go into the descriptive static frequencies. Okay, and move the. I think that there is a high correlation between the 3 and the 4. Okay, move there. So in the frequencies table, IV3 and IV4. If you look at the frequencies, completely dissatisfied 2, completely dissatisfied 2, dissatisfied 17, dissatisfied 19, and no opinion 71, 72, complete satisfied 52, 52, satisfied 167, and 1. Almost there is a high correlation between the frequencies of IV3 and the frequencies of the IV4. So now it is another testimony, a proof that there is a high correlation between the IV3 and IV4. It means that the multicollinearity exists in this data again. Dear friends, so these were the three methods through which we come to know that the multicollinearity exists in this data. First method our was VIF, correlation, and the last tool was your frequencies. Now, it means there is a high correlation between the IV3 and the IV4. Hence, it is causing the multicollinearity. How to solve this problem? Again, it's very easy. Go into the analyze and regression, linear regression, and just remove 3 or 4, because I told you the only solution is removing the any variable which is causing multicollinearity. Here, the 3 and 4 are causing either remove the or exclude from analysis IV3 or IV4. It will solve your problem. Alternatively, you can go and recollect the data for the IV3 or IV4. Again, this may solve your problem. So I'm sending back this IV4 to this prior position, and then statistic, okay, multicollinearity is already selected, that's fine, and then press OK. So now here, after applying the regression again on this now this data where I removed or I excluded the independent variable 4 from the analysis, go into the coefficient, and then here you have a look that there is no any multicollinear in your data because all the values are below the range. Range is 10. So now the collinearity between the collinearity means the relationship between the two variable, strong relation has been removed from this one, and now the VR values are pretty good. After removing the multicollinearity, now this data set is available here where I have not included the IV4 in my data set. So now the problem has been solved, and then I personally suggest you that whenever you're going to apply the multiple regression, please meet all the 8 assumptions. Otherwise, your data, the results of your data will be invalid. So therefore, it's very important all the time to follow all these 8 assumptions. Thank you very much.